Hey everyone, welcome to 3D Studies. Today we are going together to look upon the chapter Circle, and under Circle we'll talk about all the theorems of Circle and this will head in one shot for classes 9th, 10, 11, 12 as this chapter Circle is very necessary. So we'll talk all the theorems, the most important ones for class 9th, 10th and 11th, 12th as on your screen showing everything. So let us start with 3D studies. Now the first theorem that we have as per the most important. So let us see what this theorem is actually saying and let us understand. Okay, now first thing is given equal chords of a circle suspended equal angles at the center. So it's simple how you have a diagram also that there will be a circle like this. You have a circle in front of you, and what you have in this, what you're presenting, the first thing is that there are equal chords of a circle that are suspended from the center. Alright, so there are two chords that are AB and CD. These are two chords and they are suspended and they are suspending two angles. So they are suspending two angles. So what are the two angles? This and this. So we'll join them. So this angle and this angles are equal. That only we need to prove in the whole question. So let us see how we'll prove this question. First of all, we'll write that what has to be proved. So we have the answer. First of all, we'll just showing you diagram and doing full question. Now, okay. All right. We have what we need to prove. First of all, we need to write that. So we need to prove that angle AOB is equal to angle COD. So this by us needs to be proven that angle, where is angle AOB? I would like to show again to you all so you do not have any type of confusion. This is angle AOB. This angle needs to be equal to DOC angle, this angle, and if this is equal, then your theorem 1 is perfect and really your answer is perfect. Alright, so let us see. Okay, so we have to prove this. So let us begin. First of all, we'll take two triangles as for to congruent them. Alright, so we have written in triangles. What are the triangles that we are going to curve? That is, I'll take, as per my prefix, I'll take the triangles that will be triangles AOB and triangle COD, which we are given to prove as an angle. Alright, so let us take triangles AOB and triangle COD. Let us see what more we can do here. So this we have to prove. Alright, now what could be given in this? Alright, what could be given in this? We can say that OA is equals to OC as they are the radii of the circle. Where are OC? Let me show you all with the another pen so you can get it easily. It is this all. Now we have taken these two triangles AOB and COD. So first of all, we'll see that we are having OA is equals to OC as they are the radii of the circle. Where is OA? This is equals to OC as they are radii of the circle. So if these two lines are equal, so similarly that also OB will equals to OD as in question you're simply written also this. So first thing clear to you all that we have got sentences that OA is equals to OC as they are the radii of the circle and OB is equals to OD as also similarly at the first one they are the radius of the circle. Now the third thing we have got in the question only that AB is equals to CD. In the question only it's given that equal chords. Alright, so we can write that AB is equal to CD. So I have written and we have given the statement as given. So what we have, the radius of the circle, the radius of the circle, and the radius of circle. So by these three, what these three actually are? So these three actually are your sides. Side 1, side 2, and side 3. So by SSS congruent formula, by SSS criteria, we can congruent these two triangles that were your triangle AOB and triangle COD. And also by this we have one thing very special, that is CPCT. So by CPCT we can write that triangle AOB is equals to triangle COD by CPCT. Very easiest theorem. Hope so you understand very easily. Now let's jump to the second theorem very fastly. Now we have the second theorem as similar as first one, but the converse of first theorem. Alright, so it's saying that if the angles suspended by the chords of a circle at the center are equal, then the chords will be equal. So similarly we'll only do one thing. What we'll do, I'll tell you, don't worry. We have to prove in this same circle, assume same circle, like I can draw it for you all. We have the same circle, but right now we have these things with the A, B, C, D, and these and this lines are given common, this all things are given. We just need to prove that the chords are same and these angles are also given as in same. Alright, let me make it again. It's very okay. Let's take white color so you can get it easily. We have the circle again in front of you and we are having two. Okay, now it's clear. These angles are given equal, then these lines are given equal, and we need to prove that AB is equals to CD. We need to prove this. Hope so you understand. Alright, so you can write similarly, but okay. Similarly, at first one we have taken the triangles AOB and triangle COD, and we have taken like AO is equals to CO, and similarly we have OB is equals to CO as they both have the radius of the circle, and then we have OB is equals to OD. We have O here, OB is equals to OD as per they are given. AB is equals to CD as per it was given. So you can simple write by, one thing more I would like to tell you, like we have in the first theorem, like AB is equals to CD, but here we have not given that. But accepting the AB is equals to CD, here we have including two radius, here we have angle AOB and angle COD, and when these two will be mixed, so we can congruent both of the triangles that were taken by us and triangle AOB, and they will be congruent to triangle COD. But here will not use SSS criteria because here is two radius and one angle, which I shown you before also. So we'll simply use SAS, that is side angle side criteria, and will congruent these two triangles, and we can simply use our best thing, that is AB is equals to AB is equals to CD with CPCT. Very easy, as it was only the converse of theorem 1. So we are able to write the answer or the solution for this theorem very easily. So hope so you understand. But remember this criteria we are using here, SAS, not SSA. Alright, now move to the another theorem of circle that is most important. Now the theorem number 4, the most important and the last most important theorem, that is saying in this, the line drawn through the center of the circle. The line drawn to the center of the circle. Let us take the center. Alright, this line is drawn from the center of the circle and it bisects the chord into two halves. As this chord is perpendicular on the base AB. So we need to prove that the chords are equal or not. So let us see how we'll do. Every of the solution had been given here. Alright, so let us see how we'll prove. So we'll first of all see, we have to prove that, what we have to prove, that MA is equals to MB, simple. So what we'll do, first of all, listen, we'll just congruent two triangles. So first of all, we are taking triangles OAM, that is OAM, this one, and triangles OBM, that is OBM, this one. So when we'll congruent this triangle, we can simple do by CPCT, MA is equals to MB. Alright, so let us see. Like, we have OA is equals to OB, but here written why? This is for you all. You have to tell me here what comes. Simple. OA is equals to OB, like here OA is equals to OB, by which? Because they are the radies. So I'm writing for you all, these are the radies. Now the second one you have AM. This one is equals to MB. AM is equals to MB. And why? Because this is something here became wrong. Yeah, because we need to prove only this. So just cut down this. Yeah, so accepting this, first of all we'll do the common one. OM is equals to OM, this is common. And the third thing which will be used by us is an angle, that is OMA. This one is equals to OMB, as they each are forming 90 degree. Alright, 90 degree. So they will be as each 90 degree, here will come each 90 degree, and by this we can congruent both of the triangles like OAM and OBM, and by CPCT we can say that MA is equals to MB. Simple. Okay, now till here your ends all the theorems of circle as per the most important by 3D studies. Hope so you like the video, and if you like, please don't forget to like the video. And what for you waiting for? If you are not subscribed the channel, go and click the subscription button as fast as you can, and also press the bell icon so you cannot miss any updates from 3D studies. Till that, I'll be coming with more new and best prefix videos as with the mind maps, tricks and tips. So don't forget to write in the comment section if you understand or you have the problem. I'll definitely bring the separate video for your understanding better. So till that, I'll be back with the next video. Bye bye.